Okay, so coordinate proof to give the most specific name for quadrilateral pres. Okay, remember our 3 steps to coordinate proof is that we need a plan, right? We need to use formulas to execute that plan, and then we were going to create a concluding statement. So let's draw our quadrilateral first. -6, 4. 3, 1. 1, -5. And -8, -2. Okay, take a look at what it looks like it might be. It looks like it might be a rectangle. Okay, so let's see how could we prove that. So we think it's a rectangle. So our plan is to prove that it's a rectangle. Now how will we do that? So we want to show 2 pairs of parallel and congruent sides and 4 right angles. Okay, and how do we show right angles in a coordinate proof? We'll show that our lines are perpendicular. Okay, so let's start with the slopes. And the slope of PR. Okay, well from P to R we go up 3, or no, sorry, down 3. And to the right 9. So the slope of PR is -1/3. The slope of RE, we go down 6 and down 2, so that's a slope of 3. The slope of EZ, we go up 3 and to the left 9, so that's a -1/3. And then PZ, we go down 6 and to the left 2, so that's a slope of 3. So right away we can see that we have PR parallel to EZ and RE parallel to PZ, and that's because they have the same slopes. We can also see that PR is perpendicular to RE and PZ, PZ, and that EZ is also perpendicular to those same ones. Okay, so those are our 4 right angles, and then we know they're perpendicular because of the opposite reciprocal slopes. Okay, so we have our 2 pairs of parallel sides, which we've determined by slopes, and we've also determined 4 right angles using slopes. Okay, and then the last thing that we need to determine is the distances, and the only reason really we need to do this is to determine that it has 2 pairs of congruent sides as opposed to 4 congruent sides, because if all 4 sides were congruent, then it wouldn't be a rectangle, it would be a square. Okay, so just to distinguish between the rectangle and the square, we'll calculate all the distances. So the distance PZ is equal to the square root of 2 squared plus 6 squared, which is the square root of 40. And for our purposes, we don't really need to simplify it. We just need to see that it's the same as the distance from R to E. Okay, so the distance from R to E is 2 squared plus 6 squared, which is also the square root of 40. Okay, so PZ is congruent to RE. And then we have PR, which is equal to the square root of 3 squared plus 9 squared, which is the square root of 90. And EZ is equal to the square root of 3 squared plus 9 squared, which is also the square root of 90. So PR is congruent to EZ. Okay, so we have shown 2 pairs of parallel sides, we've shown 4 right angles, and we've shown that we have 2 pairs of congruent sides as opposed to all 4 sides are congruent. So our concluding statement is Pres is a rectangle because it has 2 pairs of congruent parallel sides and 4 right angles. Okay, so the next one. Use coordinate proof to give the best name for quad with points 1, 0, 2, 5, 5, 7, and 7, 4. Okay. So it certainly doesn't look like a parallelogram. So I'm thinking it's either a trapezoid, or I guess it could possibly be a kite, but it doesn't really look symmetric enough to be a kite. Okay, so to prove a trapezoid, we need to show 1 pair of parallel sides. And now remember, we have 2 other specific types of trapezoids. One is an isosceles trapezoid, in which case we'd have to show that the legs were congruent using the distance formula. The other is a right trapezoid. So if we could show that one of the angles is a right angle, really 2 of the sets of lines are perpendicular, then we could show that this is a right trapezoid. So let's really this is all in slopes right now. So we could start by looking at the slopes. So the slope from U to A goes up 2 over 3, so it's 2/3. The slope from A to D goes down 3 and over 2. From Q to D, QD slope is up 4 over 6, which simplifies to 2/3. And the QU slope is up 5 over 1, which is a slope of 5. Okay, so let's take a look at the slopes that we have. We see that we have UA and QD are parallel, right? So UA is parallel to QD because they have the same slope. But we could also see that UA and QD are perpendicular to AD because of the opposite reciprocal slopes. So UA and QD are perpendicular to AD because of the opposite reciprocal slopes. Okay, so we have a pair of parallel sides, and we also have some right angles going on in here. We don't need to do anything with distances here because we can conclude just from this information that this is a right trapezoid. Okay? An isosceles trapezoid wouldn't have a right angle. So our concluding statement is quad is a right trapezoid because it has one pair of parallel sides and a right angle. Really, it has two right angles. And that's done. Okay, last one here. We want to show that what snow is. We want to determine what snow is. And I'm going to change this to a 6 instead of a 5. All right, so -3, 2, snow, -2, 6, and 2, 7 is O, and 1, 3 is W. Okay, looks like we have some sort of parallelogram going on here. Okay, so we want to determine if it's just a parallelogram in general or if it's a specific type of parallelogram. So as always, we're going to start with our slopes. Okay, so the slope of SN, we go up 4 and over 1. So that's a slope of 4. NO, we go up 1 and over 4. OW, we go down 4 into the left 1, so that's -4 over -1, which is just 4. And SW is 1/4. Okay, so we can conclude SN is parallel to OW, and NO is parallel to SW. Now notice there's nothing perpendicular here, right? Because even though 4 and 1/4 kind of look like they might be, but remember we need opposite reciprocals. Okay, so we just have two pairs of parallel sides. And we want to know what kind of parallelogram is this. It could be a rhombus. It looks like it might be a rhombus. So for that, we're going to need distance formula. Okay, so the distance from S to N, or the length of SN, is the square root of 1 squared plus 4 squared, which is the square root of 17. From N to O, we have 4 squared plus 1 squared, which is also square root of 17. OW, we have 1 squared and 4 squared, which is 17. And last but not least, we have SW is 4 squared plus 1 squared, which is the square root of 17. So SN is congruent to NO, is congruent to OW, is congruent to SN. Okay, so in conclusion, snow is a parallelogram with 4 congruent sides and no right angles. Okay, well, what kind of parallelogram is that? Snow is a rhombus because it has 2 pairs of parallel sides, 4 congruent sides, and no right angles. Okay, and that no right angles is important in distinguishing between a rhombus and a square.